Okay, today I would like to introduce you about power amplifier. Please open your textbook and write down something for your understand and for your summarize and for your the handbook, hand textbook. When you have the testing, you can open and write down. Okay. And the content of today's chapter objectives, we have 4 points, 4 parts. The first part, the difference between classes A, B, and C amplifier, CD, something like that. And the second problem, I would like to introduce you about amplifier distortion. What is meaning? Distortion, this is the trend form of the output waveform. And the third part of this chapter, this is related to efficiency of various classes of amplifiers. And the last, this is power calculations for various class amplifier. And please write down for you a little bit, okay? Even I will send to you the file of this lesson, but I would like you to write down some words or something like that in your textbook. It's meaning today you pay attention in our lecture, okay? And I would like to introduce you. Look at the slide. You can see the transistor. Of course, you said me about, please, this very familiar with you, okay? Very familiar. The symbol, the first this of the symbol. This symbol of the power transistor have the circle. Have the circle is meaning they have a larger, a big, a great the energy in the output. You have the difference between the normal transistor and power transistor. Power transistor have some kinds, you can see here, some kinds for dispersion, the temperature. That's why they have a little bit, they have the little bit, the place where you can have some place for dispersion temperature when the temperature increase when the transistor working. And you can see some kind of the transistor, and this kind very small power energy, and larger you have the larger. And you can see here, oh, I'm sorry, this is the phone of the Vietnamese. You can see here VCE, and this is voltage and the output current. And you can see this is for small signal. You have the only 40 watt. But for the larger, this is the power electrons. You have the larger, this is 60. And for very big power transistor, you have the 250 watt. Different between the power transistor and the transistor. This here depend on the power, right? Power and energy. And of course, you can see the current. different, increasing. You can see. That's what you can, this is ampere. And you can see a little bit the PD max, maximum. This is a watt. Maybe here, this is a voltage. And of course, this here for small signal, you can have got the frequency. This here for voice, and this here for kilohertz, megahertz, and this here larger. This here hertz. Here, this here only hertz for MÉCH. And you can see what the first power transistor have a different a little bit in comparison with the, wow, it's a little bit comparison with the, wow, I am, this is some mistake here. Okay. And in the indicated, you have the different and data sheet now and volt ampere characteristic transistor. You have comparison. This transistor have power efficiently. We have the volt ampere characteristic. This is, if you see here, it's meaning volt ampere characteristic for emitter configuration or collector configuration. We have the one, this is the output current, and you have the output volt ampere characteristic. These have the output current and have the VC. What is meaning? This meaning the limited, maximum current limited, and the maximum voltage, output voltage. The area in this data sheet giving, you know about the second breakdown area. This area is meaning you cannot to choose the key point. The key point only here, for example, and here, but you cannot choose the key point, the outside of the area. This is better for us, okay? And this data sheet giving for you, that's why don't worry about how you will use. About introduction, definition, and what is meaning. Amplifier, of course, you know about to make larger the input signal, and the output signal have the different. And we have the box. For example, for one circuit, input in the left side and output in the right side. For normal amplifier and for power amplifier, we have the system cascading, for example, like that. For example, AN, and the output here, we can have the difference. This we call it, this is the amplifier, and the last cascade, the last block amplifier to connect with the resistance lot, we call it power amplifier. Its meaning conversion amplifier. This conversion, this is a final amplifier to increase, to have a responsibility to increase. We are called it this year power amplifier. Its meaning the last before the output. We call it this block, this amplifier, AN. We call it power amplifier. And usually we have the case of ideal efficiently. What is meaning efficiently? Efficiently, we are called it efficiency coefficient. Nu is equal the power energy output divided on the input energy. We call it this efficiency. And usually, following the theoretical, we have the 100%. But in the fact, not, because on system here and there are a lot of system and equipment. We have the temperature dispersion, tức là sự phát tán về nhiệt. That's why we have the efficiency below or lower 100%. And we call it, what is meaning? Amplifier, power amplifier and amplifier circuit. It's meaning power amplifier circuit. This is the last circuit before the resistance lot, before the lot. This is the output stage. We have the multi-stage amplifier, right? And we have the last before the output stage. We are called it, this is a power amplifier. And we have there are a lot of type of the power amplifier. And power amplifier we specified it for class. We call it class A, class B, AB, and AB, C, and DS. We have different kind, different class. What is meaning class? Amplifier, this is a normal. For example, we call it one circuit. For example, my question, please answer me by textbook, okay? Look at in the, wait. Look at in the my picture. This is a very simple circuit, right? And here, I have just what my question. Please answer on the textbook, okay? And I will not here and put for you the some point. What kind of the configuration and what kind of the biasing in this have just a draw circuit? The biasing and configuration. Please answer. Answer, please. Hello, hello, everybody. You look. Answer me or not? I yes, okay. I see. Only one? common collector fixed bias. White collector, common emitter. Punya is good. Yes, fixed bias. Okay, Quyền. Okay, finish. You can see this year, usually this year, once more, this year output here, collector. And on the left, this is base. And it's meaning this year collect base emitter common and fixed biasing. Fixes biasing. They classified, you look at please here, the class A. What is the class A? Class A. Class A. This meaning, please draw, follow me. This is class A. This is a V out. Have the full form way, not distortion. Là méo, không bị mất tín hiệu. Class A is meaning output and input the same, right? And if you can see here, for example, this here A, this is information. This here B, C, D. We have the full C, D, A, and B. We have collect this year class A. If the output voltage, you can see this year input is here with the color green, and the output voltage. We have the full form way, have no distortion. It's meaning we collect this circuit belong the class A. A is very good, right? And in class A, this is a full information, the output and input we can receive. Okay? And next, you can see, we can class B. When distortion have 50%. You can see like the rectifier, like the input signal have the A, B, C, D information. And here you can receive only A and B. And CD, you have lost. You have lost information. We are collect distortion. This year, portion is a called 50%. This year, no distortion, zero distortion. Zero distortion. And here in the class B, we have the output voltage have a half sin wave only. This is only a half sin wave. We call it that this is a class B. And if you know about, we have just a full, but the efficiency only 25%. Very, you know, efficiency, it is a P out divide or P in. And of course, 100%. We have this only 55, 25, very lower. And in the class B, we have maybe more than percentage, 70 larger, 78%. This year larger, right? It's good, but they lost, they have a distortion. And the pupil can mix and combine class A and class B. We have the class A, B. Wow. This year, we have the class AB. And in our case, for example, B, C, CD here, for example, and D here, C here, D, and we have the E, F. We have the A, B, C, D, E, F. This here for information, input signal. You can see here input signal. And when we design the class AB, it's meaning in this class, we have received A, B, C. But you can lose D. And E, for example, F, we can receive. And we lost, we have lost D information. That's why here this portion might be more than 60%. And the efficiency they have larger 78%. It's very good. We can mix, right? And you can see in red color output the other kind of the circuit. You can, this here class AB2, and this class we have the cross distortion, méo xuyên tâm, bị méo tín hiệu output. This is a distortion of the output waveform, and we lost B, and we have C, D, C, D, we have ready, and E, F. What is meaning? It's meaning we mix A class and B class for receiving the lower distortion, but the higher a little bit, the efficiency coefficient. This here larger in our case. You can see if class AB here we lost information D, we lost, yeah, and here we lost information B, this B, because the B belong nearly zero level, right? That's why we mix, for example, class A, we have the full wave, no distortion, but the coefficient of efficiency very low, 25%. And we have the class B. This depends on the waveform output. The waveform output have give only a half in sync. And that's why we have distortion 50%, and efficiency might be larger, 58%. And they design, combine A class and B class power amplifiers. And we expect to receive in the output signal have distortion very lower, right? No distortion. And maybe distortion only 30%, maximum 30, 25, 22%. And we willing to receive, distortion reduce, right? And willing increase. We willing to increase efficiency increase. And in our case, you can see very interesting. I can receive the form wave in the output in this situation. Yes, and only in this one or two equation we can see the distortion. Maybe in the here we call it cross méo xuyên tâm các em, cross distortion. This is meaning in the information, the nearly zero level can lose. You can lose, but you keep A, B, C, A, C, D, E, F. We have six of information, and now we have the 5. We lost B information, right? We lost one information B in the second graphic. And in the first graphic, we lost the one information B. We call it this year AB class power amplifier. And related C and D, related and CDS. C, this year class C. Class C, this year output form wave, different kind. You can see here, the output form wave, very interesting. They didn't to repeat the form wave of the input signal. Input signal have the sinusoidal. You can see sinusoidal here, here, here. But the output signal, you can see a little bit different. Maybe this is 0 and increasing like the pulse. Like the pulse negative. And you have the form. This is a distortion. Nearly 100%. But the efficiency very high, larger. This is very good, but if we use this power amplifier, in our case, we use it for the trigger circuits, để dùng để làm những cái xung kích. Tức là những cái mạch này thì có tín hiệu ngõ ra với các em, nó khác xa với tín hiệu ngõ vào. Em có thể nhìn thấy có thể là xung gai màu đỏ, hoặc là có thể cái xung mà nó nhọn mà nó không phải là hình sin. Nó cũng có chu kỳ nhưng nó không phải là hình sin. Thì người ta gọi cái mạch này là mạch khuếch đại công suất lớp C, D và lớp S. Thì chữ S là tên của nó là switch, là đóng mở đấy các em. Như vậy nó thường dùng cái mạch mà khuếch đại công suất trong trường hợp mà CDS để làm mạch kích xung, kích dẫn, mạch trigger đấy, mạch gọi là để push off một cái mạch nào đó. And for detail, I would like to explain. For class A, please do not very main some the main meaning. It's meaning the coefficient of the efficiency. And from the 25 to the 55. Class A, the output signal varies of full 360 degrees of the input signal. And in our case, you can see, Q point this here, the middle of the DC or the AC energy, lot light, right? And you can see, if you remember, determine the wayput out form, wayput out form, the output waveform. You can write the input signal is like sinusoidal. this. And the information maybe A, B, C, for example, C, D. On this information, you have the equation and you receive on the output. This is A, this is a B, this is a C. For example, if you should be to remember, and the output, for example, A, B, C, D. And of course, you receive on the output the same A, B, C, and D information. We are collect. This is class A. Its meaning Q point is a cone. The current MÉCH swing is a cone. Maybe if in general, if you know about this here, the VCC, and here VCC divide RC plus RE. This is a current, and VCE MÉCH swing. You should be to remember is a cone VCC divide 2. Its meaning our energy can put here and receive the full of energy. Output information keep on, and we have the signal have the full in the input signal. It meaning have no distortion. But in our case, if you know about the efficiency, we have the PO, PAC, divide P input. This is a 100%. And we have the coefficient of efficiency very lower. That's why because why? Because we should be to make energy to put the bias for IBQ MÉCH swing. It's meaning Q point in the middle. We have the position on this. Class A is meaning Q point in the middle, MÉCH swing. And related class B. Very interesting. This class B, once more, you can see this system, the Q point in the cutoff position. And you can see the output signal had the negative the negative part. This negative part to belong. This we have the DCLL, right? And this on this to have the area. This area belong the off area of the transistor. Its meaning on information A, B, C, D, we have loosened. We receive only A and only B in the output, and C, D signal input we have lost. What is meaning? Is meaning we collect class B. In this class B, we have the efficiency larger, but the 50% of this percentage of signal distortion. You know, this is a halfway only we can receive. And the keyboard bias the off region, please, not for you in your textbook, because this definition usually using in the multi choice question. Okay, and its meaning class B, the Q point now in the off region. You can determine the ICQ is equal 0. Or the VCEQ is equal nearly VCC. This is a class B. That's why the biasing very important. If you design the circuit, for example, this is a circuit, this is a voltage divider biasing, for example, for the general, we have, yes, and here the VCC. But when you put the biasing, for this circuit, you have Q point in this position. It's meaning the position, the system now is biasing in the cutoff region, in the off, and no working. But the information can amplify it if you give. And of course, exactly not exactly is equal 0. This is equal E mean. Exactly. You can have the position of the Q point. Q point here is equal 0, and Q point is the current Q. And we have the output current, very smaller. And this information in the output signal, we have only A and B. If sample, we have the A, B, C, D. And now on the output, we receive only A and B. We are correct. The system have the output power energy in the class B. Class B have the distortion 50% and have the coefficient of efficiency larger 60, or from the 50% to 60. It's good, but you have the distortion 50. Why not good? Because you lose information. Okay, and the first class A is the max swing Q point. If the B, this is of biasing region, and class AB, what is meaning class AB? We have two kinds, and class AB, an amplifier may be biasing at the DC level above 0 base current level. You can see here, if you design this here, we are called as class AB. It's a mix AB. It's meaning, if you see here, the Q point here, and I know can design from you. We have, you can follow me a little bit for quickly, because you take only 30 seconds and you have the answering 1.2 point. What? You can see VCE. And draw for me, please, is the current. And we have on the time, we have the VCC. And here VCC divide RC plus RE. Wow. On the time, you have quickly draw this DCL. And for our case, this here middle. This here middle, right? And of course, related the AC energy, we have the green color. This here AC. We have the circuit AC, LL, and we have DC, LL on the time. And we can send trust on biasing only, okay? And this here for class A. This here for class B. And our case situation, this is Q point for class AB. If for class AB, you can draw. I am quickly. I would like you. I would like you follow me because I would like you to have the good marks in our course. Very easy. You can see Q point here. This here medium between the mark swing and the cutoff. Yes. And we have the input signal here. Some minute. It's okay. And now you can follow me. This here parallel. This here octagon. This here we can VCE. And here the current. No, this here the time. This here, please follow me. And here you make the parallel and the other circuit very quickly, right? Very easy. You can here put the current, this here, the real output current. What is meaning? Real output current is meaning the real output current on the time. This here the output AC plus ICQ, right? And that's what you, when you draw, this is very easy. And you put here. Wow. Yes. And you put here, this here, time, and time. But you have here, this here, ICQ. And here, you have the VCEQ, this Q point. We call it this E class B. This is very small, but I draw maybe the large. For example, I have the input signal. Larger. Smaller, of course, it's okay, but I would like to show you why we call it this is class AB. The input signal with the information A, B, C, D. For example, this is input A, B, C, D, information. And this information to make, we are draw. Following me. We have a receive here. And the signal to go to B, for example. C, okay. But here, this is to go to the area of the cutoff. We have the area of the cutoff. And that's why on this information and on this information, we will lose. And in the output, we receive here. And here you can go to for the voltage. This here we are collect for the full wave. Here we have this. Here, this here A point output, and B here, and C here. But we lose D. Why? Because we have the information D to come to here. And the D point, you can see the D point to belong the area of the cutoff. This area between this here QB class and here. That's why we have know this area, and we receive on the output the information A, the information B, information A, information B, and information C. But information D we have lost, because on this information to go to here, the current is we are lost, and that's why they're very easy. You can see this here answering. You take only 1 minute. 1 minute for answering. Draw the output from wave with distortion. And when you see that, we call it this is circuit design with the output power related class AB. And class AB Q point should be to have the biasing between the max swing and the cutoff, the Q point, this area. And we have the Q point here. This is between, this is a lower max swing. And lower max swing we can receive in the part. We have lost the area. We have lost the area in comparison with the input signal. This input signal. The other kind of the class AB, and you see very interesting. In our case, the distortion in the area we are call it cross distortion, and it's meaning information in this area nearly zero level can be lost, and we have received only A, B, C have lost. See if we have nearly here, it's meaning they have lost. We have this in Vietnamese, this is cross distortion, and this is distortion of the output waveform. You remember when we make some exercise, sometimes I ask you determine and draw the output waveform with distortion. It's meaning for normal circuit, for the on amplifier, we have the information in the output with distortion. Of course, for this kind, we can design a very small input signal with red color, for example. And this input signal we can receive. Okay, you can receive this without distortion, right? Right? The input signal, the output signal, we can receive all information. For the red color, we call it this system. For the red color input signal, we call it this is the class A. Because the output, for example, here, the same circuit, the same information, A, B, C, D, E, F, for example. And in the output, we receive the full A, B, C, D, E, F. For the red, this is input, the red color input, and the red color output signal. We call it, this circuit, for this information, for this input signal, we design a class. You should be to know about this, a class. Its meaning depend on input signal and depend on cue point position. We can use this, our amplifier, in the case of the class A, in the case of the class A, B. Listen very carefully. That's why in your mind, we have the A class, AB class, and the class C. The output of class C amplifier is biased operation less than 130 of the circle. And you can see, usually in our case, we have the cue point deeply in the cut-off area. It's a very interesting. Deeply is what is meaning deeply. Wow, you should be a little bit understand. This graphic. On the time you should be to remember, and on the time and any question you should be to put. We have the DC, right? Deeply cue point, maybe cue point here. And you can see, usually we have the cue point, QA. This is a middle QA class. And QB, nearly the cutoff. Yes, and QAB here. Yes, and our Q C, D, or S. These are deeply in the cut-off area. Deeply. Maybe we're going to hear deeply too. And of course, the form way, of course, we have no correlated sinusoid. A class D and class switch S. This operating class inform amplifier open pulse. Digital. You can see pulse. Yes. The pulse. And the class B form operation that the amplifier on using power only for a short interval and overall efficiency can practically be very high. You can see if QA we should be to pay a lot of biasing DC energy because we have this here IBQA, right? QA, this is class A, right? And DC energy for class B, of course, very low, right? Here, because the EV mean, the current means QA. And of course, the AB, of course, is the middle, not lower, not higher, in the middle, PBA. In our case, deeply here. That's why we use only short interval, and overall efficiency can be practically to be very high. Very high. And it's meaning, you know, in your summary, you can see CDS. This year, the output waveform have the distortion 100%. But the coefficient of efficiency very higher because they use the input signal DC energy very small, shortly only. Okay. And now, why? Please draw for you. Related a circuit of the class A, you can draw, giving the circuit. This is biasing without resistor. This is a fixed biasing. If I put here, this is no problem. This is with case RE. This is no problem. And sometimes this is a divider circuit. This is no problem. Given the circuit, please determine the outputs from way. If we know this circuit working in the A class, you make the normal system. And you have, wow, I'm very sorry because this is a form not oh, this is on in Vietnamese language. Okay, I will sign out and to give you some information on the equation. Please follow me. You should be to output. This year, please follow me. This year, power okay. Wait a moment. Wait a minute. I would like to delete a little bit related to Vietnamese. Sometimes I would like to put the Vietnamese this year for you understanding, but not okay. I can reduce. I can to delete. Okay, and wait a few moments. I think okay. And now we are continue a little bit, and please try again. I would like to give use some very shortly the content for remember, and when you have the testing or final examination, you can open your textbook or open my file and know about this equation, and you can put the value and accounting very quickly. Okay. Now, we should be to determine the power output. It's meaning you should be to determine where is the power energy. You put please, because this is the real time. That's why you can see here the VCE very smaller because the current, because this is the AC energy, alternating energy. This is output signal. You know about this circuit, our circuit here. This is the first question. This is determine Q point. If we know this, the first question. This is the Q point. If we know about this here, the emitter common VCEQ and determine DCLL if we know this year class A. Very easy. When we have class A, it's meaning we have the QMS, right? But following the output signal this year, we should be to know about the output signal. That's why we have DC. This is the number we should be to determine. And we have the open here. Why? Because in the max wing, and we have the full option, right? The output signal peak. We have the V peak here, peak. And that's why this equation on the time you can approve. Các em có thể công nhận cái phương trình. Đây là người ta tính cái công suất của ngõ ra, và công suất của ngõ ra đối với tín hiệu xoay chiều, và giá trị VCE và IC này nó có giá trị là giá trị của dòng xoay chiều cực đại. Thế thì ở đây người ta mới nói nè, đây là giá trị hiệu dụng. Và như vậy giá trị hiệu dụng thì người ta phải lấy nguyên cả một cái chu kỳ là peak ở trên đầu và peak ở phía dòng điện và điện áp đều tính bằng peak. Tức là điện áp đỉnh của 4 phần. Và căn 2 là giá trị hiệu dụng chúng ta đo được, tức là bằng 2 nhân với 4 lần thì bằng 8. Như vậy cái mẫu số này của chúng ta bây giờ nó là 8. Và V peak tức là giá trị của công suất ngõ ra mà tính bằng tích phân, tức là tính giống như là diện tích của toàn bộ cái sóng ngõ ra đấy các em. Thế thì các em hãy viết vào cho cô một cái công thức mà để mình nhớ luôn, để đến khi mà nếu mà mạch khuếch đại công suất lớp A hay là mạch như thế nào đó thì điểm Q luôn luôn là trung điểm. Thế xác định tính điểm Q thì chúng ta biết rồi. Và cái thứ hai nữa là mạch khuếch đại công suất lớp A có thể là cái điểm Q nó nằm xịch ở phía dưới, tức là bởi vì người ta cho rằng cái tín hiệu ngó vào nó nhỏ. Nếu các em nhớ lúc nãy cô có đây có một cái hình là trên cái hình mà phân tích là mạch khuếch đại công suất lớp AB. Mạch khuếch đại công suất lớp AB là mạch có điểm Q nằm ở giữa điểm max swing và điểm ngắt. Thế thì cái điểm Q của chúng ta màu đỏ nó nằm ở đây này. Đối với tín hiệu màu xanh lá cây á, tín hiệu ngó vào màu xanh lá cây á các em, thì nó là mạch khuếch đại công suất lớp AB. Nhưng đối với tín hiệu màu đỏ thì mạch là khuếch đại công suất lớp A. Còn đúng không nào? Thế thì bây giờ chúng ta quay trở lại cho mạch như hình. Chúng ta quay trở lại cái bài toán là cho mạch như hình. Câu số 1 là xác định tính điểm Q. Đúng không? Câu số 2 là câu số 1 là xác định tính điểm Q. Câu số 2 xác định tính Q rồi biết là mạch khuếch đại công suất lớp A. Thế nhưng mà cái điểm Q này chúng ta cũng phải tính toán bằng công thức. Còn nếu như bảo mạch được khuếch đại, cho mạch khuếch đại công suất lớp A thì lại khác ạ. Cho mạch khuếch đại công suất lớp A thì ta hiểu như vậy, cái điểm A lúc này là ở trung điểm. Còn nếu người ta chỉ hỏi là cho mạch khuếch đại như hình, xác định tính điểm Q, viết và vẽ phương trình đường tải tĩnh. Đúng chưa nào? Và khi mà người ta nói viết và vẽ phương trình đường tải tĩnh, thế xong là câu số 2 sơ đồ tương đương tín hiệu nhỏ gì đấy. Sơ đồ tương đương tín hiệu nhỏ gì đấy. Câu số 3 người ta mở ngoặc, người ta hỏi là xác định tức là determine the power amplifier if this power amplifier is the class A. Câu số 3 là xác định công suất nếu như mạch công suất này ở lớp A. Thì lúc đó chúng ta biết là cho dù điểm Q nó nằm ở đâu đi chăng nữa, nhưng mà đối với sóng ngõ vào là sóng màu đỏ lúc nãy thì coi như là nó không bị méo, thì ta gọi là mạch khuếch đại công suất lớp A. Thế thì trong trường hợp như thế này thì các em áp dụng cho cô công thức này. Áp dụng cho cô công thức Trong trường hợp này là mạch khuếch đại. Trong mạch khuếch đại công suất lớp A thì ta có QMS là VCOQ bằng VCC chia 2, ICQ bằng VCC chia 2 RC, và công suất nguồn á, công suất nguồn ở đây người ta tính như thế này các em. Công suất nguồn thì bằng giá trị của nguồn nhân với ICQ, và ICQ ở đây là ICQ trung bình, và hiệu suất thì bằng cái POAC và trên PIDC nhân 100%. Đây là cái công thức. File này cô sẽ gửi lại cho các em để các em biết cái vị trí. Và đây là một trường hợp mà cho mạch khuếch đại công suất. This is given the power amplifier with this circuit on fit. The first question, determine Q point. The second question, determine the power energy. For example, power energy. And the third, power energy output. And the first maybe determine the equivalent, draw equivalent circuit and determine the AV. Of course, you can determine very easy, right? And sometimes they ask ZE or Z out. This is very easy because you know about this, right? And the fourth question, maybe determine where is the influence, the cutoff, the determine the frequency F high and F low, for example, like that. Wow, this question we cannot determine, but I will give you the information very briefly. Don't worry about this. And finally, maybe determine the output firmware. Draw the output firmware. Of course, this output firmware you have ready answering. This here input. This here input sinusoidal, right? And outputs we have the same full. And this here voltage. This here we have the full, and output voltage and input current, output current have the trend 180 degrees, right? This here phi, this here waveform. It's meaning you can finish answering 5. You can, of course, answering the first. Of course, you can the A 2 because of following. You can see we have the maximum, the output voltage. Output voltage, this is output AC. And if determine PDC input, you can hear the input max. Please write down for your textbook. This is very important for you, for not. And this is, of course, one question you cannot. The first question, of course, you should be to finish. And for on this exercise, this exercise you can solve on them 10 minutes. Because you have already on equation, but you should be to find out where is equation. Have the first very important equation. This is the equation, the input and the output voltage. This is a max. Max here they improve. They improve for you. That's why don't worry about this. And this is the position of the Q point. If the circuit given power amplifier class A given only this case you can determine this here Q point, this here Q max swing, and DCLL, right? And if the same circuit, you can make different answer. Given this here the second, this here given the circuit, the amplifier is meaning you should be to determine Q point. You should be to determine Q point following 3 steps. Following 3 steps. The first step, this here, determine the biasing equation, right? For example, in this circuit, I can give you some information, this first question. And the second question will be determine PAC is equal to PCC is equal. If we have A class for the input signal, you remember? And in this way, you can approve a different. You will should be to take VCEQ and ICQ different. And this here, the value you should be to multiply. You can have the PC energy. The ECQ multiply VCEQ. And if you have in our case, you have the PAC, the same. The same in our case, you can VCC and divide on RT and divide on A. You have the VCC equal. In our case, we have the output signal. And this output signal have depend. And this here depend on, we call it in our case, this here is equal RL. And the same piece AC. And we have the coefficient of efficiency very lower and maybe increase a little bit between the 25% or 50%. And of course, the second exercise more than difficult for you. And I think enough. You can understand only one case. Only one case. This one case, very easy for you. This you can apply the equation and put the equation, the value, and account this circuit. Okay. This first circuit related. And of course, the output form wave. And you can see the circuit, the class A. But this here, C common, and this here, the E come on, the output signal. Wow. The output signal signal and the input signal have the form the same. And if you can see with the output circuit, we have no changing the phase. This is any collector come on. And the output signal to take from the collector, from the emitter. And here you have the emitter come on. And the output signal changing 180 degrees Celsius. You can see on the two guys, we have only one volt-ampere output characteristic. And you can draw the input signal had A, B, C, D. We have all information. In our case, A, B, C, D, E, for example. And the output, you can receive A, B, C, D. This is how you can receive on the top. Okay. We have just listen about the class A with the simple circuit. And similar, if we have the fixed bias with a resistance AC, with the resistance, and you have fixed bias voltage divider biasing, you can determine the circuit in this. And even collector common or emitter common, we have the full output signal. We are finished the class A power amplifier. And now we have the time break.